Hidden beneath the ice of this single body of water was enough explosive power to incinerate the northern hemisphere. The Soviet Union didn't call the Sea of Okhotsk an ocean, they called it a bastion. It was a fortress of silence, a geographic cage where their nuclear submarines could hide, wait, and, if the order came, end the world in 30 minutes. No American ship was supposed to enter it and linger. No sonar could penetrate its geographic defenses. The Kremlin believed this water was a locked vault. But in 1971, a team of American divers didn't just break in. They walked up to the front door and stole the keys. In the strategic calculus of the Cold War, this sea was the ultimate sanctuary. The Soviet Navy seeded the floor with acoustic listening arrays. They patrolled the surface with hydrofoil destroyers. They mined the straits. They did this for one reason: to hide the apocalypse. Deep beneath the ice, the Soviet Union patrolled its boomers, nuclear ballistic missile submarines. As long as they remained undetected in the Okhotsk bastion, they guaranteed a second strike capability. They were the insurance policy of mutual assured destruction. American naval doctrine designated this sea a denied area. Previous incursions by U.S. submarines had been brief, terrifying games of tag. To stop here, to anchor, was considered operational suicide. But in October 1971, a single American submarine slid silently past the Kuril Islands and entered the bastion. It wasn't looking for a ship. It wasn't looking for a missile. It was looking for a sign. This is the story of Operation Ivy Bells. It is the story of how the U.S. Navy retrofitted a submarine without a mission into a saturation diving habitat, battled the laws of thermodynamics to tap a cable without touching it, and stole the Soviet Union's most guarded secrets. And it is the story of how a billion-dollar dominance was shattered not by a better weapon, but by a man with a bankruptcy filing and a photographic memory.
Welcome to the edge of the impossible. This is Apex Engineering.
To understand the engineering insanity of Ivy Bells, we must first understand the intelligence gap. In the 1950s, the NSA lived in a golden age. Soviet communications were transmitted via high-frequency radio waves that bounced off the ionosphere. The U.S. could sit comfortably in Turkey or Japan and listen to the chatter. But by the late 1960s, the airwaves went silent. The Soviets, paranoid about interception, moved their command and control traffic to microwave towers and underwater cables. The NSA was deaf. The U.S. Navy knew the Soviet Pacific Fleet was maneuvering, but they no longer knew why. The intelligence community identified two critical nodes. Node A, Petropavlovsk-Kamchatsky, the isolated submarine base on the volcanic peninsula. Node B, Vladivostok, the Pacific Fleet headquarters on the mainland. To connect these 2 points by land, a wire would have to traverse thousands of miles of Siberian swamp and permafrost. It was a logistical nightmare. Soviet military logic dictated the path of least resistance. The shortest distance between Kamchatka and the mainland is a straight line across the Sea of Okhotsk. The Soviets believed the seabed was secure. It was protected by the depth, the cold, and the territorial sovereignty of the bastion. The U.S. Navy knew the cable was there. The problem was finding a 5-inch wire in a sea the size of the Gulf of Mexico. Trawling for a cable in the open ocean is a needle in a haystack scenario, where the haystack is mined. Using active sonar to map the bottom would announce the American presence like a flare gun. The solution did not come from a supercomputer. It came from Captain James Bradley of the Office of Naval Intelligence. Bradley applied a principle of civil engineering pragmatism. He remembered his childhood on the Mississippi River. He remembered signs warning barges not to drop anchor near utility lines. He reasoned that the Soviet Navy faced a mundane threat, their own fishermen. A heavy trawler anchor dragging through the mud could sever the strategic link to their nuclear fleet. Bradley hypothesized that the Soviet paranoid state had to be pragmatically visible. They had to mark the cable to save it from their own citizens. The ONI scoured open-source intelligence, maps, coastline photos, maritime charts, and then they found it. On a desolate stretch of the northern Okhotsk coast, a sign standing alone in the tundra. Niyakoritsa, kabel. Do not anchor, cable. It was the apex insight. The Soviets had painted a bullseye on their own secret. By projecting a line from that sign into the deep water, Bradley had a vector. Now he just needed a ship crazy enough to follow it. Standard attack submarines are designed to hunt. They are hydrodynamic sharks. They are not designed to stop. Ivy Bells required a platform that could hover motionless for weeks and support human life at crushing pressures. The Navy turned to the USS Halibut. She was a strange beast. Originally built to launch the massive Regulus nuclear cruise missile, she had a giant watertight hangar on her foredeck. When the Regulus program was canceled, Halibut was a ship without a mission. But that empty hangar, nicknamed the Bat Cave, was exactly what the Special Projects engineers needed. It was a massive garage in a world of cramped tubes. They filled it with a saturation diving chamber, turning a warship into a deep-sea laboratory. The first engineering hurdle was station keeping. A submarine is neutrally buoyant. If it stops moving, the slightest current will push it off course. To tap a cable, the Halibut had to remain frozen in 3D space, inches above the mud in total silence. Engineers installed two radical modifications. First, fore and aft vertical thrusters. These acted like the rotors of a helicopter, allowing the pilot to make micro-adjustments to depth without using the main propeller, which would have churned up the silt and blinded the divers. Second, the anchoring system. Submarines are not designed to land. If they touch the bottom, they usually break. The engineers welded massive steel skegs, essentially giant sled runners, to the bottom of the hull. These acted as landing gear, but simply resting on the skegs wasn't enough. The currents would roll the ship. So they installed fore and aft mushroom anchors operated by heavy-duty hydraulics. This created a terrifying moment for the crew. To anchor, the Halibut had to flood her tanks, become negatively buoyant, and essentially crash land on the seafloor in slow motion. The noise of the steel skegs hitting the crust of the seabed sounded like a car crash inside the hull, metal screaming against rock. Every time they landed, the crew waited. They waited for the sound of rushing water indicating a hull breach, or worse, the sound of a Soviet sonar pinging investigating the noise. But landing had even a deadlier risk. The seabed was thick, colloidal mud. The danger was breakout force. If the submarine settled too deep into the clay, the suction could exceed the vessel's buoyancy reserves. The mud would refuse to let go. The Halibut could be glued to the bottom, trapped until her air ran out. The water in the Sea of Okhotsk is near freezing. 34 degrees Fahrenheit. At this temperature, a human in a standard wetsuit dies in minutes. But the problem wasn't just the water, it was the gas inside their lungs. To prevent nitrogen narcosis, which acts like drunkenness at depth, the divers breathed heliox, a mix of helium and oxygen. But helium is an atomic thief. Helium has a thermal conductivity 6 times higher than air. It strips heat from the human body with brutal efficiency. If a diver breathed cold heliox, the gas would freeze his lungs from the inside out. He would die of hypothermia while standing in a dry room. The engineers had to design active thermal protection. They didn't try to keep the divers dry. They flooded them with heat. The dive suits were free flooding. The submarine pumped hot water, heated by the nuclear reactor's steam exchange, through an umbilical cord directly into the suit. The divers lived inside a personal flowing bath of 100 degrees water. It was a fragile lifeline. If the pump failed or the umbilical snagged on a rock and snapped, the diver had roughly 3 minutes to return to the bell before their core temperature collapsed and they lost consciousness. The helium also warped the physics of sound. The speed of sound in helium is much faster than in air, which raises the resonant frequency, the formants of the vocal tract. It made elite Navy divers sound like cartoon characters. Communication was impossible without signal processing. The Navy installed helium unscramblers, electronic processors that shifted the frequency of the diver's voice back to a human range. Without this, the captain could not understand the men risking their lives a few feet below his hull. The psychological strain was absolute. The silt on the bottom reduced visibility to inches. One diver, working alone in the freezing black, reported seeing a glowing, pulsating green shape drifting toward him. Paranoia took over. Was it a Soviet drone? A secret weapon? It turned out to be a bioluminescent siphonophore, a deep-sea colony organism. In the pitch black of the Okhotsk 4, nature itself looked like enemy technology. After days of searching the silt with remote-controlled fish, they found it. A black, armored cable, 5 inches thick, looking like a garden hose dropped in the mud. Now, they had to steal the signal without breaking the wire. The Soviets monitored the electrical integrity of the cable. If the Halibut divers cut the wire to install a tap, the circuit would break. The Soviets would know instantly. If they pierced the rubber insulation to touch the copper, the seawater would create a ground fault. The Soviets would know. The engineers needed a way to read the electricity without touching the conductor. They turned to Faraday's law of induction. Physics dictates that when an alternating current flows through a wire, it generates a magnetic field around that wire. This field contains the exact same information as the current itself. The U.S. engineers built the inductive coupler. By wrapping a secondary coil around the outside of the Soviet cable, the changing magnetic field of the Russian voice traffic induced a matching current in the American coil. It was a ghost tap. No physical contact with the copper, no change in impedance, no alarm in Vladivostok. The initial taps were small, proof-of-concept devices that retrieved days of data. But the intelligence was so rich, the NSA demanded a permanent listening post. As the mission evolved into the 1980s and the USS Parche took over the route, the technology scaled up. They built
the pod. It was a masterpiece of Cold War engineering. A 6-ton cylinder, 20 feet long. Inside, it held massive reel-to-reel tape recorders capable of capturing weeks of multi-channel data. But you cannot plug a 6-ton computer into a wall socket at the bottom of the sea. The pod was powered by RTGs, radioisotope thermoelectric generators. It ran on the heat of decaying plutonium-238. It was a nuclear-powered recording studio left on the enemy's doorstep. There was one final danger. What if the Soviets raised the cable for maintenance? If they pulled up a 6-ton American device, it would be an act of war. The pod was designed with a mechanical release. If the tension on the cable changed, indicating it was being lifted, the clamps would automatically spring open. The pod would fall off and sink back into the mud, leaving the Soviets to hoist a clean, empty cable.
When the sub returned to Maury Island, the tapes were rushed to the National Security Agency at Fort Meade. The crypto-analysts prepared for the worst. They expected the Soviet Navy to use the most sophisticated encryption algorithms in existence. They expected weeks of decoding. They pressed play, and they froze. The voices on the tape were speaking Russian, but they weren't speaking in code. They were speaking in the clear. No encryption, no scrambling, just open analog voice traffic. The Soviet commanders had made a fatal assumption: security through obscurity. They believed the Iron Bastion was impenetrable. They believed the cable sitting on the secure floor of their own territorial lake was as safe as a landline in the Kremlin. While high-level strategic orders were encrypted, the day-to-day operational chatter, maintenance reports, morale issues, supply shortages, was wide open. The intelligence yield was catastrophic for the Soviet Union. The U.S. Navy didn't just hear orders. They heard the health of the machine. They learned which ballistic missile submarines were seaworthy and which were broken. They learned the maintenance schedules. Crucially, they learned the patrol routes. This nullified the concept of the second strike. The entire purpose of the nuclear submarine is stealth. If you know where it is, you can kill it. The Ivy Bells tapes effectively painted a target on every Soviet SSBN in the Pacific. In the event of World War III, the U.S. Navy could have preemptively neutralized the Soviet sea-based deterrent before a single missile left the tubes. This intelligence became the ultimate card in the high-stakes game of arms control. In the late 1970s, during the SALT II negotiations, Soviet diplomats would bluff about the capabilities of their missiles. They would claim a new guidance system was fully operational. The American negotiators would sit quietly, knowing, because they had heard the designers discussing the failures on the phone, that the system was actually prone to overheating. They could call the bluff without ever revealing why. Years later, when Ronald Reagan took office, this intelligence stream hardened into doctrine. When Reagan famously said, "Trust, but verify," Operation Ivy Bells was the verification. It was the ability to look the enemy in the eye and know with mathematical certainty that he was lying. The operation ran for nearly a decade. It survived the presidencies of Nixon, Ford, and Carter. The torch was passed from the Halibut to the USS Parsh. The Soviets never found the pod. Their acoustic arrays never heard the intruders. The billion-dollar secret was not defeated by superior Soviet engineering. It was defeated by American bankruptcy. Ronald Pelton was a communications specialist at the NSA. He possessed a photographic memory, near-perfect recall for numbers and details, but his personal life was a wreck. By 1979, he had resigned from the agency. He had mishandled his finances, was building a home he couldn't afford, and was $65,000 in debt. He was facing total ruin. On January 14, 1980, he made a phone call to the Soviet embassy in Washington, D.C. The FBI intercepted the call, but they failed to trace it in time. Pelton walked into the embassy. He didn't bring documents. He didn't bring blueprints. He didn't need to. Pelton sat down with KGB officers and recited the details of Operation Ivy Bells from memory. He described the Halibut. He described the saturation divers. He pointed out the specific geographic location of the pod. He sold out the crown jewels of U.S. naval intelligence. And the price? For the secret that neutralized the Soviet nuclear deterrent, the KGB paid Ronald Pelton approximately $35,000 in initial payments. It was the price of a mid-size sedan. Pelton sold out the safety of the Western world for pocket change. The Soviets didn't act immediately. They waited, likely to protect their source. But in 1981, the U.S. National Reconnaissance Office directed a spy satellite to sweep the Sea of Okhotsk. The analysts looked at the photos and their blood ran cold. The imagery showed a massive concentration of Soviet naval units. A salvage fleet was anchored precisely over the coordinates of the tap. They weren't fishing. They were retrieving. The Navy could not send the USS Parsh back to investigate. That would have been suicidal. The satellite photos were the tombstone of the operation. The pod was gone. The Soviets had it. Pelton was eventually caught in 1985, identified by a KGB defector. But his trial presented a legal nightmare known as graymail. To convict him, the U.S. government had to prove he gave away classified information. But to prove that, they had to reveal the classified information in open court. They had to publicly admit to violating Soviet territorial waters, an act of war. The prosecution had to speak in euphemisms, referring to Sea of Okhotsk projects, without ever saying submarine or pod. Pelton was convicted and sentenced to life in prison. But the damage was done. The Iron Bastion was closed. Today, the Ivy Bells pod is not in the Smithsonian. It is a trophy in the Central Museum of the Armed Forces in Moscow. A physical monument to the moment the U.S. Navy got too close and the human factor failed. The Cold War ended. The Soviet Union collapsed. But the mission did not stop. It merely changed physics. In the 1990s and 2000s, the world's information migrated from copper wires to fiber optic cables. The Internet does not run on electricity. It runs on photons. This presented a crisis for the NSA. The inductive coupler relies on magnetic fields generated by moving electrons. But photons, light particles, do not generate an external magnetic field. You cannot tap a fiber optic cable with a magnet. To tap the Internet, you have to touch the glass. Enter the USS Jimmy Carter. Commissioned in 2005, she is the spiritual successor to the Halibut and the Parsh. She is a Seawolf-class submarine, the most advanced predator ever built. But she is a mutant. She is 100 feet longer than her sisters. Inserted into her hull is the multi-mission platform, a massive floodable hangar designed for ocean interface. Like the Halibut, the USS Jimmy Carter is equipped with auxiliary thrusters for station keeping. She can hover over a fiber optic backbone in the deep Pacific. Inside the multi-mission platform, technicians or autonomous robots can access the cable. How do you tap glass without breaking the connection? Intelligence analysis suggests a technique called macro bending. You don't cut the fiber,
you physically bend the cable to a specific calculated radius. This exploits a loophole in the principle of total internal reflection. If the bend is sharp enough, the light can no longer bounce off the cladding walls. A tiny fraction of the photons leak out into the darkness. It's not enough to disrupt the Netflix stream in Chainan or San Francisco, but it's enough to be captured by a receiver in the dark water. The copper ghost tap has become the optical light leak. The silent service does not speak of these missions, but occasionally they signal. In April 2017, the USS Jimmy Carter returned to her home port in Washington state. Flying from her mast was a large pirate flag, the Jolly Roger. In submarine tradition, the Jolly Roger signifies a successful combat mission. The Jimmy Carter had not fired a torpedo. She had not sunk a ship. So what had she done? She had likely been to the bottom of the ocean, in someone else's backyard, touching the nervous system of the world.
Operation Ivy Bells was a triumph of apex engineering. It combined the audacity of James Bradley's deduction, the brute force of the Halibut's conversion, and the elegance of the inductive coupler. It proved that in the atomic age, there are no sanctuaries. There is no depth deep enough, no water cold enough, and no bastion heavily defended enough to keep out a determined engineer. But it also proved a darker truth. You can build a titanium hull to withstand the pressure of the ocean. You can build a nuclear reactor to heat a diver's blood against the cold. But you cannot engineer a defense against the human conscience or the human wallet. The most dangerous component in the system was not the submarine, it was the man.